Good morning, everyone. I'm Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. In today's lecture, we are going to see about output feedback and counters. So this is also the part of topic present in modes of operation in block cipher. Output feedback. Here, the messages are treated as a stream of bits. Output of a cipher is added to message and the output then feedback. First, what we are doing means we have to do the encryption. So the plaintext is converted and the key is inserted. So after that, we are finding out the ciphertext. So the feedback is independent of message, so it can be computed in advance. So the uses of this output feedback is stream encryption on noisy channels. So it has any noisy channels means in that place this output feedback will provide a good thing. An alternative to CFP is output feedback. That means cyber feedback is output feedback. So it generates the random bits and independent of the message being encrypted. So this output feedback mode is similar to structure that of cyber feedback. Expect that the output of the encryption function is fed back to the shift register in OFP, and in cipher feedback the cipher text unit is fed back to the shift register. So both the things are just opposite. So this is the pictorial representation of output feedback. So here what we are doing means the noisy and non state. So first what we are doing means we are inserting a data along with key inside the encryption. So after encrypting that, the plaintext is added with that encrypted form. Then we are converting that as a ciphertext. So again, that encryption feedback is taken for the next one. So that can be passed as a message. So with that message, we are inserting a key. Again, we are inserting a plaintext with that. Then we are getting the ciphertext. So like that, we are performing plaintext to ciphertext conversion, and also for decryption the just opposite form we are using. Advantages and limitations of OFP needs an IV which is unique for each use. If ever reuse attacker can recover outputs, so OTP can pre-compute, so bit errors do not propagate, more vulnerable to message stream modifications. Change arbitrary bits by changing ciphertext. Sender and receiver must remain in sync. Only use with full block feedback. Subsequent research has shown that only full block feedback should ever be used. Counters. The counter mode is a variant of output feedback, but which encrypts a counter value. Although it was proposed many years before, it has only recently been standardized for use with AES along with the other existing four modes. So it is being used with applications in the synchronized transfer mode, that means ATM, network security, and IP security. A counter equal to the plain text block size is used. The only requirement state is SP838A, as that the counter value must be different for each plain text block that is encrypted. So typically the counter is initialized to some value and then incremented by 1 for the subsequent blocks. So in the output feedback mode, what happens means initial counter value must be a nonce, be different for all of the message encrypted using the same key. Further, all counter values across all message be unique. A value is used multiple times, then the confidentiality of all the plaintext blocks corresponding to that particular counter value may be compromised. A new mode throw proposed early on, similar to OF but in counter value rather than any feedback values. It must have a different key and counter value for every plaintext block is different. Again, OTP issues occur. The use of this counter is high-speed network encryption. So this is the pictorial representation of counter. So here what we are doing means we are adding a counter with every encryption path. So we are encrypting key along with the counters. In that, with that we are inserting a plain text. So it converts plain text into the ciphertext. So likewise, we are encrypting, and in the opposite versa, we are doing the decryption. So the advantage and limitations of counters are it is efficient, can do parallel encryption on hardwares and softwares, can pre-process in advance need, good for bursty high-speed links, random access to encryption data blocks will be allowed, provable security. So it provides a security. It never have a cycle less than 2 power b and must ensure never reuse keys and counter values otherwise could break. Thank you. So from this lecture you can understand about how we are using the counter and nonce environment along with your block cipher. So here what we are doing means by using the block and nonce, first we are inserting a key and we are performing the encryption. After that only we are adding a plain text. So then we are converting that in the form of a ciphertext. So in this form we are working on it. Thank you.